Lesson 2 has us adding and subtracting radicals. You can only add or subtract like radicals. That means that the number under the radical sign has to be the same. So it has to be exactly the same radicand in order for us to add or subtract them. If they are not the same, we are not able to add or subtract them. Indexes must be the same too. So for example, the square root of 3 and 2 square root 3 are like radicals because they both have a radicand of 3. Now before we do our first example, I just want to bring back when we were adding and subtracting variables. Recall that in order for us to add and subtract variables, the letter had to be exactly the same. That's the same idea that we're going to do with our radicals. So as we look at this, we have x plus 2x. Now, no visible coefficient is the same as a coefficient of 1. So as we go to do this, we have 1x plus 2x, which gives us 3x. Our first example has us looking at adding two radicals together. Now the first thing we need to do is check to make sure the radicands are exactly the same. And in this case, they are both 3's. So we would be able to add them. So once we've checked that, the next thing we're going to do is we're going to add the coefficients. So we're looking at 2 plus 3, and then the radicand stays the same. So 2 plus 3 is 5, square root 3. There is our final answer. Not all of our questions are going to start off with radicals that are like radicals. As a result, if they're not like radicals, we're going to want to change them into mixed form if possible, so simplify them as much as possible. This may result in radicals that can be added or subtracted, or it may result in radicals that cannot be. So we look at our first example here. We have square root of 2 plus square root of 8. 2 and 8 are not the same, so at this stage we are not able to add them. However, 8 is a number that we can simplify, so if we do that, 8 factors are 2 times 4, and 4 is 2 times 2. So the square root of 8 can be written as 2 times 2 times 2 under the radical sign. Again, our index is 2, so we're looking for two numbers that are exactly the same. And so we have two 2's that we can circle, and they can move out. And we have one 2 that has nobody to go with, so it has to stay behind. So our circled 2's move out, become a single 2 on the outside. Our other 2 stays behind. So we now have the square root of 8 has been simplified into 2 square root 2. So if we go back to our original question, we had square root of 2 plus square root of 8. When we go to look at that, square root of 2 did not change, so it is still square root 2. But instead of writing square root 8, we can replace it with 2 square root 2. Notice that the sign in front of the square root 8 did not change. At this point, we can now look at our radicands. They are the same. They are now both 2's. Recall no visible coefficient is the same as having a coefficient of 1. So at this stage, we can now add them. We have 1 plus 2. And then our radical stays the same. So we have 1 plus 2 is 3, square root 2. And there's our final answer. You don't just need to add or subtract two radicals, you can add or subtract more than two radicals. So if we go to look at our next question, we have 4 radicals, and all the radicands are different. So at this point, none of them are like radicals. So we're going to take a look, see if we can simplify any of them and make them like radicals that we can combine. So if we start with our 2 square root 98, we're going to have to start off with our 98. And 98 is 2 times 49. 49 is 7 times 7. So 2 square root 98 would be equal to 2. On the outside is our coefficient. We have 1, 2, and 2 7s underneath. Remember, no visible index is the same as an index of 2, which means 2 of the same can get circled. We have our 2 7s, get circled and move out. Those circled 7s, as they move out, are going to join the 2 that's already in front. So we have 2 times 7 square root 2. 2 times 7 is 14 square root 2. So there's our first one. The next radical we have in our question is the square root of 10. Now you may, looking at the square root of 10, know whether or not it simplifies. And that's good. If you're not sure, that's okay too. We can list it as its prime factors, 2 times 5, and take a look at those prime factors. Now remember, in order for us to circle anything to move out and simplify, we need to have multiples that are the same. We only have 1 2 and 1 5. And so if I write that under a radical sign, there is nobody for that 2 to go with and nobody for that 5 to go with. So nobody gets circled, and we are left with just the square root of 10. So that one didn't actually simplify. So those are our first 2. We have 2 more left to look at. Our next one is 5 square root 8. So as we go to look at 5 square root 8, 8 is 2 times 4, which is 2 times 2. So we can go 5 square root, and instead of writing the 8, go 2 times 2 times 2. Still an index of 2, so we're looking for buddies of 2. So these two 2's can go together, get circled, move out. But that last 2 has no partner, and if it has no partner, it has to stay behind. So the 2's are going to go join the 5 that's out front. So we have 5 times 2. The uncircled 2 stays behind, leaves us with 10 square root 2. We have one last radical to take a peek at, and that is 3 square root 40. So if we take a look at 3 square root 40, 40 is 4 times 10, 4 is 2 times 2, 10 is 2 times 5. So we still have a coefficient of 3, but now instead of 40, we're going to have 2 times 2 times 2 times 5 under our radical sign. And then looking for partners, pairs, groups of 2, exactly the same numbers that can go together. We have 2 2's, so these guys can go together and move out. We have another 2, but no partner for that 2, and we have a single 5. Okay, so it has no partner. We still have that coefficient of 3 out front. The circled 2's move out to join it. And then underneath, the uncircled 2 and the uncircled 5 stay together. Our last step for this one will be to multiply the numbers together so that we have a single number as a coefficient and a single number as a radicand. 3 times 2 is 6. 2 times 5 is 10. We have now checked all 4 radicals, simplified as the ones that we could. So now if we go back to our original question, which was 2 square root 98 plus square root of 10 minus 5 square root 8 minus 3 square root 40. So there's our original question. What we're going to do is we're going to go through and we're going to replace each of those radicals with their new simplified radical. Everybody's going to stay in exactly the same spot. So no signs are going to change. Plus and minuses are going to stay in the same place. 2 square root 98 had simplified to 14 square root 2. Plus sign, so we still have a plus sign. Square root of 10 we figured out did not simplify. Minus sign, so we still have a minus sign. 5 square root 8 became 10 square root 2. And then we have a minus sign, so minus sign. 3 square root 40 became 6 square root 10. So there is the exact same question now with the simplified radicals. So as we go to look at this, we can add and subtract like radicals. So we have these two. They both have a square root of 2 in them. And then we have these two that both have the square root of 10 with them. Now, as we think about our numbers, the sign goes with the number directly behind it. So, for example, if we think about 2 minus 3, I could write that as negative 3 plus 2. So that negative sign, minus sign stayed with the 3. So as we move things around, and we can in our question so that all the like terms are beside each other, we want to make sure the sign stays with the number directly behind it. So if we look at it, we have 14 square root 2. If I put the other square root 2 right after it, that would have been our 10 square root 2. We have the minus sign in front of the 10. So we're going to go minus 10 square root 2. And then looking at our next one, we have our plus square root 10. So plus square root 10. And then the minus went with our 6 square root 10. So minus 6 square root 10. So we still have all of our square root 10s together. And we still have all of our square root 2's together. And the signs in front of each of those numbers has not changed from the previous line, just the order in which we wrote them. So now as we go through, we can add or subtract the coefficients. Radicand stays the same. We have 14 minus 10 gets me 4 square root 2. Remember, no visible coefficient is the same as a coefficient of 1. So that would be 1 minus 6. 1 minus 6 is negative 5 square root 10. So we've combined those. We've now got down to 1 square root 2, 1 square root 10. The last thing we're looking at is whether or not those two can be combined. They are not like radicals, so as a result, we are now stuck leaving them as they are. So there's our final answer. In summary, when we were adding and subtracting radicals, the first thing we were doing was simplify the radicals, so make them a mixed radical with the radicand as small as possible. We then added or subtracted the coefficients of the like radicals. And remember, the radicand then stays the same. It doesn't change, just the coefficients do.